So my focus for this last chapter for the section 1 of the course is on elasticity, or if we wanted to find a synonym for that, we'd be really talking about sensitivity. Or, we know that from the law of demand, for instance, that decreasing the price increases the quantity demanded. Or, the decreasing the price increases the quantity demanded, and that decreasing the price decreases the quantity supplied from the law of supply. But the question is how much, right? And this is a different issue than the slope. Here we're talking about not the quantity change for the price and the quantity change for the quantity, but rather percentage changes. So I'd ask you to go back to the appendix to chapter 1, the mathematical appendix, if you have questions about how to calculate percentage changes. I'm going to be quite relaxed about how you calculate them. If you want to use the graphing calculator to tell you how to do that, absolutely fine. This isn't percentages 101 class. You can do the new minus old over old to find percentage changes, whatever method you want. Perfectly fine with any method, as long as it gives me a reasonable approximation of percentage changes. But what we're going to focus on here then is understanding first how to calculate it, what the numbers mean, and then why economists care about elasticity so much. Okay, so to start, elasticity, when you hear that word, what you should be thinking of is sensitivity. And we're going to be primarily concerned with 4 types of elasticity here. We're going to be concerned with the price elasticity of demand, the price elasticity of supply, the cross-price elasticity, and then finally the income elasticity. So probably what I'll do here is I'll probably break this down into 2 parts here in terms of the lecture. But here's what we're going to be looking at. We're going to be looking at the various sensitivities as they apply to the demand curve, the supply curve, how goods are related to each other, how changing the price of one good will affect the quantity demanded of another good, right? And we would be thinking that primarily we're going to be interested in whether goods are substitutes or complements. And then finally the income elasticity. Well, that would give you an indication we'd probably be concerned about whether goods are normal goods or inferior goods. Okay, so probably what I'll do here in this first lecture, part 1, is I'll focus on these first 2. In the second part of the lecture, I'll focus on the latter 2. Okay, so I did make it a point to say that this is a different issue than slope. Slope is talking about like rise over run, or the absolute changes in quantity demanded, absolute changes in price, or the numeric value, right? So we can see here, right, that for this product it obviously has a constant slope. It's a straight line. But if we were doing the slope, right, we'd be talking about a number here, right? Let's say it's going from 15 to 10, right? Then we'd be talking about a change of 5. And it was going from, let's say, 30 to 40. Here we'd be talking about a change of 10, right? And then we would say, well, the slope then in this case, right, it's in terms of rise over run, would be negative 1/2, with the negative sign signifying that it's downward sloping. The price elasticity of demand, or what I'll call E subscript D, is going to be the percentage change in the quantity demanded over the percentage change in price. Probably an easier way to do this, and this is just one possible way of many others of how to calculate a percentage change. However you want to do it is fine by me. Is that you could multiply by 100 the following ratio. The changes in, I would give you 2 points, and you would take the change in those two quantity demanded, right? The changes in the two prices, and then multiply it by the original price over the original quantity, and then multiply that whole thing by 100. What that would be useful for then, for you to see then, right, would be that you would know that the elasticity demand, because of the law of demand, is always going to be negative. It's always going to be negative. But that the range of this function is going to be anywhere from 0 to negative infinity. And those numbers are going to have different regions that apply to them on the graph, and the numbers are going to have different significance for us as economists. In our big graph here, in the exact middle, we're going to have the elasticity of demand where it's equal to -1. This is going to be called unitary elasticity. And what that's going to tell us is that for a 1% change in the quantity demanded, there's a 1% change in the price. So it's a 1-to-1 ratio. It's neither insensitive or sensitive, right? It's just equally sensitive and unsensitive, I guess you could say. In this region here, what we can understand this here as negative infinity, and then this region would be -1 to negative infinity. Now what does that say? If you're way over here, let's say point A, what that would mean is that, right, in this case, a very, very small, very, very small change in the price would elicit a very, very large change in the quantity demanded. In fact, at the intercept, it would be infinitely large, negative infinitely large, because of the price changes. So if I increase the price, the quantity demanded would fall by a negative infinity amount, primarily because it's, the quantity demanded would be close to approximating 0. In this region here, where it's -1 to negative infinity, this is going to be called our elastic region of the demand curve. When something is elastic, that means that it's sensitive. Changing the price by 1 unit causes a greater than 1 unit change in the quantity demanded. At the intercept, it is what we would call perfectly elastic. 1 unit change in the price causes an infinitely large amount of change in the quantity demanded. And then we would have a region where it's from negative, where the elasticity demand is equal to -1 all the way to 0, somewhere in that range. It would be on this lower portion of the demand curve. And this would be considered the inelastic region. That would mean that changing the quantity demanded is relatively insensitive, causing changes to the quantity demanded. So changing the price doesn't change the quantity demanded by very much. And then finally, all the way at the x-intercept, it's equal to 0. And at that point, we would call it perfectly inelastic. That would mean that changing the price causes no change in the quantity demanded. Now, what we can see here, right, in this picture here, right, is that you would then have a number, right? Let's say that I gave you a number like the elasticity of demand is -5. Then what you would be asked to do is identify where it is in the demand curve and what that number means for us. So at a number of -5, obviously we can identify that this would be somewhere in the upper portion of the demand curve, or the elastic region of the demand curve. And what that means quite simply is that for every 1% change in the price, there's a 5% change in the quantity demanded. It is the elastic region of this demand curve. Now, let's look then at like how we would calculate something like this. Right, is the way that you would be given this then is that you could be given quantity demanded changes from I have here my quantity demanded increasing and my price falling. So take a few moments, start to calculate that. I'm going to pause this and I'm going to come back with the solution. Okay, so what you can see here is that I've decided to solve my percentage, do my percentage changes here with the equation of the delta Q, delta P, P over Q, with this being the original price, this being the original quantity. So in my elasticity of demand equation, then I have 12, which would be the change from 40 to 52, -3 being the fall from 15 to 12, times the original price, which was 15, original quantity being 40, with my elasticity of demand equaling -1.5. So now what does that number mean? That number means that for every 1% change in the price, there would be a 1.5% change in the quantity demanded. That would make this number, since it is less than -1, but greater than -infinity, right, or put it in absolute value terms, is greater than 1, but less than infinity, means that it is elastic. And that would mean that it's going to be on the upper portion of our demand curve. Pretty darn close to the midpoint, but at least above it. Okay, so the question then becomes one of, right after seeing these kinds of things, the question would be, well, what makes two demand curves, right, if we were to look at two different demand curves? We know that they often are shaped a bit differently, and that we could imagine a demand curve that looks like this, another that looks like this, and another that looks like this. Right? Three very differently shaped demand curves. One where the slope, now I'm saying slope, looks about like -1, let's say, right, for the whole function. Here the slope for the whole function, since these are straight lines, the slope is the same at each and every point. Here the slope would be very, very steep, and here the slope would be very, very flat or very, very low. Now the question is that if you were to have two graphs, or two demand functions, graphed on the same graph, So if I were to have something like a demand function for good 1 and a demand function for graph 2, for two goods, you can see that one is steeper than the other. Now, because these demand curves cross with one another, we can, without knowing, right, although each of these have elastic and inelastic region, because all demand curves have those regions, when two demand curves cross one another, we can use their steepness as a way to also talk about their elasticity relative to each other. In other words, when a graph is steeper relative to another demand function, we can talk about them being more inelastic than, right, in this case, demand 1 is more inelastic than demand curve 2. And the reason why that is because for the same change in the price, let's say it's a $1 change in the price, that you would imagine various small changes in the quantity demanded for D1, but very large changes in the quantity demanded for D2. D2 would be more elastic relative to D1. Notice I'm saying relative, so I'm having them cross each other and I'm comparing them across each other. Now, the usefulness of this is that we can then talk about some goods being elastic and inelastic relative to other goods. That would be things like, right, what if I had like a heart condition and I needed a heart medication, right, versus my love for my Chairman Mao clock, right? For my Chairman Mao clock, he actually waves when you wind it here. He actually waves his, he used to, I think he's broken now, because it's clearly ringing. Right, for the Chairman Mao clock, I would argue that that is a relatively elastic good compared to my heart drug. The reason why is, right, that regardless of what the price is for my life essential heart drug, right, I'm going to pay the price because I need to live, right, or I want to live. Versus my Chairman Mao clock, which is just a novelty item, right, and there's lots of clock alternatives, or it could even go without a clock, right? So what we want to talk about now are if we have two demand curves, one more elastic than the other. So we have a D1, D2 comparison here. D2 being more inelastic than D1. The question is what is it that made D2 more inelastic relative to D1? Well, there are 5 major reasons why. The first and foremost, and one that I kind of highlighted in the example I just gave you, is the availability of substitutes. If there are many, it would be more elastic. Obviously, if there are fewer or none, right, if it's a patented drug, then there are no substitutes, then it is relatively inelastic. The perspective on time, the time frame that you're talking about, the more time you have, the more elastic you're talking about, right? If I were talking about what is my demand for transportation this week, right? Basically, I'm going to be relying on my car, right? I've got 2 cars. I've got 2 really junky cars, right? I could rely on either my Civic or my Volvo, right? Either one, but I don't really have that many substitutes. But if we're talking like a 5-year time frame, right? We could talk about me having like a new car, right? Or I could get a Segway and ride a Segway all around, right? Get a moped. There's lots of options the longer the time period. Same with like apartments, right? We could talk about the fact that like I am stuck in my apartment for my 1-year lease, right? So over the course of this until next June, right, I'm basically stuck at my apartment. I have no substitute places I can live. I'm stuck at my place, so I'm inelastic till my lease runs out. But once my lease runs out, right, I have much more elastic demand for housing, right? Because I could buy a house, live in a igloo, right? There's lots of different things I could do. An igloo. The other would be an idea of what is a necessity versus what is a luxury. Obviously, if something is a luxury, it is more elastic, right? Because with a luxury, we could say, well, we don't really need it, so if there was a significant change in the price of that good that made it more or less expensive, let's say it made it more or more expensive, then I probably would just stop buying the product because, right, in this case, there are lots of other goods that I could buy, goods that I need to, maintain my life, the necessities of life. Another would be the portion of the budget that it consumes or takes up. Here, the larger the share that it takes up, the more elastic it is. And the reason why that's the case is we're often talking about things like, how often do I think about the amount that I put into parking meters, right? I don't think very much about it because it's only like 20 or 30 cents, right, for a certain period of time. And if Menominee was going to increase it by 5 cents for every 5 minutes, big deal, right? I make much more than 5 cents an hour, right? And, so for me, an extra nickel isn't that big a deal. But what if Menominee was going to say that all apartments need to have like a $300 surcharge for municipal services? Well, since rent is already a large portion of my budget, I'm likely going to be quite sensitive to to changes in that price, in the change of the price for my rent, right? So the larger the portion that it consumes, the more sensitive I'm going to be to those changes. And then finally, right, we could also look not only at the portion of my budget, but also at the scope of my budget. Right? And for the scope of the budget, what we're talking about here is the category itself. Are we talking about housing versus my apartment rent, right? Or are we talking about for transportation in general? Or are we talking about the amount of transportation I do by train or by mule or whatever, right? And what we're going to say here is that the more narrow the category, the more elastic I'll be. So that would be something like, right, if I'm just talking about my, for scope of budget, if I'm just talking about my transportation budget in general, my general budget category of transportation is inelastic because I need to move around, right? I'm not just going to be a loser and just stay in the same place all the time. But now if we're talking about my demand for transportation by airplane, right, then at that point I'm really elastic. I'm very sensitive to changes in the price of airlines because I could always fly, a private plane. I could, take the train, drive, put myself in a box and go UPS, right? There's lots of different ways that I could transport myself. And so we're talking about a very specific category of transportation. I'm more elastic than just transportation in general. Okay, so probably a more significant question for you, especially for most of you, given that you're not economists, would be why should we even care about any of this, right? What is the usefulness of an elasticity number? Well, the reason why it's going to be useful for us are two reasons. For many of you, especially for those of you who are in retail management, marketing, business courses, and that's your major, then the most useful thing that you're going to get out of elasticity, and I would argue that if you really don't get very much out of this course except this one thing, this is something that in business courses, other business courses that you take, others would be quite impressed by your knowledge of this economic concept. So with that said, pay particular attention to this. It's going to be useful for determining whether you're going to change your price. Knowing whether the product you sell is elastic or inelastic is going to be useful for you recommending to your manager, we should increase the price or we should be resistant to changing our prices. Think about 2 examples. Now we could just do very extreme examples here. I could be the airlines right during the 2007 time period. During that 2007 time period, the price of oil had increased dramatically, yet airlines were unable to change their price and to reflect those higher gasoline prices. Now, why would that be the case, right? Because if they have higher costs, shouldn't they just be able to charge higher prices? But what all of the airlines know is that the good that they sell is relatively elastic for a number of reasons. First, we as consumers really don't care that much about what airline specifically we fly, right? I mean, some of us, I like to fly Southwest personally, right? But, I'll buy whatever is the cheapest, and that's what most people will do, right? They might look at convenience as well, like the flight times, but most people are going to care more about the price. So everyone's competing heavily on price. Each airline knows that they face many competing flights from different airlines, so there's a lot of substitutes available to consumers. Consumers, as a whole, we just saw with scope of budget, don't care as much, right? If they're talking about specifically about airline transportation, there are other non-airline ways of getting places. And so consequently, they were unable to change their price, because if they had changed their price, think about it, if it's an elastic good and they had changed their price, then they would have seen a huge change in the quantity demanded. More specifically, had they raised their price to reflect the higher gasoline prices, they would have suffered a huge decrease in the quantity demanded, which would have led them to probably declaring bankruptcy, those who hadn't already. The alternative would be, what if I was selling then, the other example for a company would be the pharmaceutical companies that are selling what they call these bone density drugs, which are used primarily by older age women that are fearful of suffering from like osteoporosis, bone density, and these drugs are hugely expensive, something like $10, $15 a pill that you have to take. Usually I think it's like once a week or once every 2 weeks. And for that company, right, the increase in the price, it can often be quite dramatic. And the reason why the pharmaceutical company can get away with this is, what are you going to do? Right, for some people, just drinking milk and eating yogurt isn't going to be enough to increase their bone density, right? It's just the fact that one is getting older and their body changes. So they need this drug in order to stop their bones from breaking. So, right, if it's higher, you're just going to pay for it, right? Because first, it's a necessity. Second, it also deals with the fact that people oftentimes aren't paying that $10 price for the drug, right? They're paying like $1, maybe $2, because they have insurance covering the rest. So it covers a very small scope of their budget, right? And we're giving you a whole list of factors now that are making it relatively inelastic. So if you're the manager for that pharmaceutical company, you're likely to recommend that the price should be increased. Okay. The other usefulness for this is something that deals with the previous chapter that we looked at. And that's looking at tax changes, right? And actually determining who is paying what portion of the tax. When a good is relatively inelastic, buyers will actually pay a larger portion of the tax. And when something is relatively elastic, then the seller will pay a larger portion of the tax. By portion of the tax, I mean the following, is that we could Right? In the previous chapter, what we saw was that we had a demand curve and a supply curve, and let's say I impose this $10 tax on the seller. Like, the seller has to legally pay for the $10 tax, right? The government is going to come to the seller to get their money. And I've drawn here two relatively, in terms of elasticity, nothing extreme, right? Nothing extremely elastic or inelastic. So I impose this $10 tax. It shifts up my supply curve. And what we would see here is P1, P2, P3, right? Is that the difference between, well, first, our original equilibrium price was P1. Nothing exciting there. Then the tax is imposed. It shifts up our supply curve by a vertical distance here of $10, which you can see is the difference between P2 and P3. It shifts it up. But notice that the price that the consumer pays has risen only to P2. And the difference between P1 and P2 is certainly not $10, right? It's the whole portion here that's $10. So what you can see here is even though the seller is being legally required to pay the $10 tax, that consumers aren't paying the whole portion of the tax, and neither are sellers. Sellers are now receiving, after they pay the tax, P3, right? But they used to be receiving P1. This difference is also not $10. So you can see that consumers and firms are sharing in the burden of the tax. What that burden, how it's shared, is dependent on the elasticity. Let me give you an example. And we'll do it for something that is, let's say, a pharmaceutical drug, something that would have a relatively I'll just draw a regular supply curve here, but a relatively inelastic demand curve, right? A very, very steep demand curve. So I imposed the tax, $10, same tax imposed. P1 was our original equilibrium price. P2 is now the price paid for by the consumer. P3 is the price received by the seller. Here we have our total tax. But now you'll see that P1 to P2 is actually most of the tax, and most of the tax is paid for by the consumer, who is more inelastic. The seller, yeah, they pay a small part of the tax, but not very much. This is in comparison to something where instead, let's say, instead of a pharmaceutical drug, it was something relatively elastic. Let's say like the demand for apples from a particular farmer, right? Unless you really love the apples from that farmer, right? I have my original supply, I have just a normal supply curve, a relatively flat demand curve. And now, right, let's actually make this, I want to make this a little bit more extreme here, so my apologies for wasting a little bit of time here. Alright, so I made a really, really flat demand curve. I impose my tax. Now you can see that the original equilibrium price was P1. Most of the tax is now paid for by the seller, difference between P1 and P3, whereas the buyer is paying very little of the tax. If you thought about it from a policy perspective, right, what you would see from that is that if you're trying to impose taxes to increase revenue, you would want to tax goods where you're trying to either influence seller behavior or buyer behavior, right? In the case of cigarettes tax, right, something where the consumer would be relatively inelastic for cigarettes, we would imagine that that governments face an incentive to tax cigarettes because, right, buyers are going to be the one who are paying that tax, and they're going to be right, as they see that tax and they're paying most of that tax, it might influence their behavior in favor of not smoking as much. Also, though, they cover their externalities, something that we saw in the previous chapter. Also, by the way, I should mention something that would be a really good test question because it's comprehensive across now multiple chapters of talking about cigarette taxes. Okay. I'm going to do one last thing here for elasticity. We're still talking about elasticity of demand. Given how long I'm talking about this, I'll probably, after this one last thing, pause it here. I'll do price elasticity of supply and the other elasticities following that. And this is something that, for the elasticity of demand, we're going to call the total revenue test. And it's related to the first reason about why elasticities are important to know about. And that's, again, with what recommendation would you make to a manager about whether you as a company should change the price of the good that you're selling. So on the y-axis, I'm going to put total revenue. On the x-axis is going to be my quantity. And what we're going to see here is a total revenue test where the elastic region rising to unit elasticity and then inelasticity. And what we're going to see here is that in the elastic region, changing the price, right, in this case we're just looking at quantity here, so that gives us an idea of how we would have to change the price, right? To get it to move from left to right, right, how would we increase the quantity demanded? Well, the only way we could do that is by lowering the price. So the question when you're reading this total revenue test is, let's say I'm right here, B, and C. And the question would be, at point A, should I lower the price? Well, at point A, if that's where your firm is in terms of elasticity, it's in an elastic region, then you would likely recommend that your manager should increase the price. Why? Because, decrease the price, sorry. If they were to decrease the price, that would have the act of increasing the quantity demanded and increasing revenue. If you were at point B, you would probably neither recommend nor advise against recommending changing the price because you're actually at the maximum revenue. In the inelastic region, you would not want to cut the price. And why wouldn't you want to cut the price? Because you're not going to get that much change in the quantity demanded. And you would see that total revenue is going to keep falling, right, if I were moving from C to D. Is that lowering the price at point C, you'll sell more, but you're going to lower the price more than you're going to gain new customers. Okay, so what we see here as a conclusion to that then is that it doesn't make sense to lower the price when you're in the inelastic region, and that it does make sense to do that when you're in the elastic region. Okay, so I'm going to pause it here and then pick it up with elasticity of supply.